Hello guys, welcome back to my YouTube channel Anveshana Academy. This is Dr. Manjunath Chennapkodu. Dear students, in the previous class we discussed what is combined mode of heat transfer. Okay, and how to calculate the combined mode of heat transfer. We know the equation and also we drawn the thermal circuit for combined mode of heat transfer in the previous class. Okay, so now we'll move towards next topic. I want to solve one numericals on combined mode of heat transfer, dear students. So one problem on combined mode of heat transfer. Dear students, there is a carbon steel plate which is having thermal conductivity of, just a minute. Okay, there is a carbon steel plate which is having thermal conductivity of 45 watt per meter degree Celsius and which is having a size of 600 mm into 900 mm into 25 mm is maintained at 310 degrees Celsius, full stop. Air at 15 degrees Celsius blows over the hot plate. Okay, full stop. If convection heat transfer coefficient is 22 watt per meter square degree Celsius and 250 watt is lost from the plate surface by radiation. Calculate the inside plate temperature. Dear students, here is a carbon steel plate. In that carbon steel plate, conduction heat transfer is going to take place. From that steel plate, heat is going to loss or heat is going to transfer in two ways. That is, one is radiation heat transfer, another one is convection heat transfer. That means what? In this application, more than 2 modes of heat transfer is going to happen. That is nothing but what? Combined mode of heat transfer. Dear students, to understand this problem, what I will do, I will try to draw the schematic diagram for the particular problem. How it is that you can see now. I will draw a diagram here, dear students. This is what my diagram for the given problem. So dear students, what I have done, there is a carbon steel plate. Yes, here is the carbon steel plate and which is having a thermal conductivity. That thermal conductivity I can mark here as a K, that is 45 watt per meter degree Celsius he has given, and he has given the size of the plate. That size of the plate is nothing but what? He has given length of the carbon steel plate is 900 mm and width of the carbon steel plate is 600 mm. Okay, and it is having a thickness. That thickness I will mark it here as a 25 mm. Okay, that you can see here now, dear student. The thickness of the plate is 25 mm he has given. That's fine. Okay, the next, then that surface temperature of that plate is maintained as 310 degree Celsius. That means what I will mark here, this is a plate, right? When you are seeing at a front view, you can see like this, right? So here is the heat source. The heat is transferring to the plate through conduction. So heat is transferring in the plate, that is conduction heat transfer. That conduction heat transfer we can calculate with help of an equation, that is Q is equal to minus Ka into dt by dx. Okay, this is the equation. Conduction heat transfer is going to take place into the carbon steel plate. Okay, so now this is heat transfer. Now when it is a plate, right, it is having inside here, at this point it is having a temperature. The temperature I will mark here as a Ti, or inside temperature of the plate, and that at top of the plate surface temperature is maintained as 310 degrees Celsius because heat is going to transfer through the metal plate. Then heat is going to transfer from Ti to Ts, but he has given Ts he has given. That means what? Surface of temperature of the surface of the plate he has given, that is 310 degrees Celsius, but he has not at all given inside temperature of the plate, but he is asking to calculate that itself, inside temperature of the plate. That means what? We don't know the Ti, we need to calculate Ti, but he has given surface temperature of plate as 310 degrees Celsius. Fine, that I have marked. Then over that plate, hot plate, what actually he is doing? He is blowing the air actually. That he is blowing the air temperature is 15 degree Celsius. That air we can call temperature of fluid, that is 15 degree Celsius. The temperature of the fluid can be represented as a TF also. Dear students, notation, some authors they will use different notations, whatever it may be. We can adopt, we can follow the fundamentals of the subject, so that it's okay. Whatever notations they will take, right, let them take. We can take our own also, no problem. Okay, fine. Then 15 degrees Celsius. Okay, then what happens, when the air is blows over the surface of the plate, right, then what happens, convection heat transfer is going to happen. So that convection heat transfer can be calculated with the help of an equation. What is that equation? That is Q convection is equal to HA into TS minus TF. TS means what? Surface temperature of plate, that is 310 degrees Celsius. Then TF means what? Whatever the air is moving, right, that air temperature, that is how much? 15 degree Celsius. Then A is nothing but what? Area which is exposed to the heat transfer. That is nothing but what? Area you can see here, dear students. What area you have to consider? At the bottom surface, or sorry, at the top surface, that area is exposed to the heat transfer, that to convection heat transfer. That can be calculated with help of an equation. What is that equation? That is A. So how much it is A now? Dear students, that area you can calculate here now. That area is equal to how much? Now it is 600 mm is there. I will convert it into meter. That is 600 divided by 1000. It becomes 0.6 meter into, again, 900 divided by 1000. It becomes 0.9. So then when we are going to multiply, right, when we are going to multiply, we are going to get 0.54 meter square. This is the area. Then thickness is 25 divided by 1000. You are going to get 0.025. That is what thickness. Okay, area is okay, fine. Next. Okay, then when it is convection heat transfer, right, he is telling that there is a convection heat transfer coefficient, that is H. H also he has given. So I will mark here now. H is equal to how much he has given? 22 watt per meter square degree Celsius. Okay, fine. Next, and some amount of heat is going to transfer, or it is going to last in the form of what? Radiation. That means what? Some amount of heat is going to transfer in the form of radiation. That TS directly has given, that is 250 watt he has given. That means what, dear students, whatever the conduction heat transfer takes place here, right, okay, conduction heat transfer is going to takes place. Once it takes place, right, that plate is exposed to the atmospheric air. That air will come and it will absorb some amount of heat and it is going to transfer to the surrounding air. That is convection heat transfer. But he has given there is some amount of heat is going to last through radiation. That amount of heat he has already given, that is 250 that he has given. If it's so, then what is the inside temperature of the plate he is asking to calculate? Okay, to do this, what I will do, I will list out the given data now. What is this TS now? Yes, TS is equal to how much he has given, dear students? That is 310 degree Celsius. Fine. Next, air, whatever the air is moving, right, that he has taken as a TF. TF is equal to how much he has given? 15 degree Celsius. That is temperature of the fluid. Okay, fine. The next coefficient, that is H he has given, that I have already taken. Then radiation heat transfer, can I write here as a QR? QR is the radiation heat transfer that he has already given, that is 250 watt, dear students. Then he is asking to calculate, to find what you need to find out. You have to find out the value of what? Ti. The Ti means what? Inside temperature of the plate you need to calculate. That is your finding. Okay, so now, dear students, what we can see here now. Now, conduction heat transfer, I will write it here, conduction heat transfer. Okay, so that conduction heat transfer is equal to, because some conduction heat transfer is going to take place here, right, that is equal to rate of radiation, that is conduction heat transfer is equal to radiation heat transfer plus convection heat transfer. The same thing I will write it here now. Conduction heat transfer is equal to radiation heat transfer or convection heat transfer, convection plus radiation heat transfer, dear students. Now, okay, it is happening now. So whatever the conduction heat transfer takes place, right, that heat is going to transfer to the surrounding through convection and convection. So I will write the equation. What is the heat transfer equation for conduction? We know already, that is minus Ka into dt by dx is equal to, what is convection heat transfer equation? That also we know. What is that? Ha into surface temperature of plate minus temperature of fluid which is moving over the surface of the plate plus radiation heat transfer. But radiation heat transfer directly he has given, no need to calculate, that is 250 he has given. Okay, fine dear students. Now what is thermal conductivity? K is equal to, he has given somewhere else, here I missed to list out, but K he has given that thermal conductivity of steel plate, it is equal to how much? 45 watt per meter degree Celsius, dear students. That also I will take it here now. So that means, so I will substitute here now. So there minus 45 into what is area? That area you can see here now. That is how much? 0.54 meter square. That is 0.54 into what is dt, dear students? Now here you can see here now dt for conduction heat transfer. Conduction heat transfer taking place here, right? That means what? It is Ti and it is Tw. That means what? Ts minus Ti, you can write it, right? So that temperature I can write it here now. So that is nothing but what I can write it here now? Ts minus Ti. So Ts minus Ti divided by what is the dx? Dx is nothing but thickness of the plate. That is thickness of the plate is 25 mm is there. You convert it into meter. So that becomes what? How much here now? That is 0.025 is equal to what is H? H he has given already. How much he has given? That is 22 watt per meter square degree Celsius he has given. That I will write it here 22 into area is equal to how much? That is 0.54, just a minute, sorry. That is 0.54 into next Ts. What is Ts? That is surface temperature, that is 310 minus temperature of fluid, that is equal to 315. That you can see here, dear students. So that you can see here now. Ts is 310 degrees Celsius, Tf is 15 degrees Celsius. That I will substitute here now. 310, Ts is 310, then it is 15 degrees Celsius plus 250, dear students. That is 250. You can take it here now. Now I will do simplification, dear students. With the help of calculator, I will try to do the simplification. What is that? That you can see here, dear students. Now, what is that? Is I will write it here. Minus 45 into 0.54, then I will write it here 0.025. Then how much I am getting here now? So here I am getting minus 972 into this I have done. Then what is left out? That is surface temperature. As 310 is the surface temperature. So what I will do? I will write that value because I know the surface temperature, that is 310. That is equal to 310 minus, but Ti I don't know. So I will keep it as it is. That is equal to what is the value of this? Just to do simplification. With the help of calculator, I will do simplification. That is 22 into 0.54 into 310 minus 15. Minus 15 plus 250. So how much I got? So that is 3754. So I will write it here 3754. Okay, fine. Now I will do simplification. That what I will do now, dear students. Then this I will remove this minus sign. How I can remove 972? Then I will take Ti this side. Then I will write it here 3 Ti minus 310. Hence the negative sign is removed. So therefore is equal to 370 3754. Okay, fine. Now I will take it out. So I will take this into the right side. That Ti minus 310 is equal to what I can do now? 3754 divided by 972. Then what will be the answer? 3754. Okay, so 3754 divided by 972. How much it will be? it will be 3.86. So I will write it here, dear students, 3.86. Then this is equal to what? Ti minus 310 is equal to this much. Then what I will do, dear students, I will keep it here now. This minus 310 I will shift to this side. So therefore Ti is equal to, so 3.86 plus 310, sorry, plus 310. Then what happens now? Add these two. So that becomes what? 13.86 degree Celsius. That means what, dear students? The temperature of, that is Ti, right? That means what? The temperature of plate at inside is 313.86 degree Celsius. Here it is higher and here it is lower. Hence the problem is correct. This is how to calculate the inside temperature of the plate for a combined mode of heat transfer. Dear students, please, if you like my videos, please do subscribe, like and comment. Thank you.